Welcome to another video in the Security Command Center series, Event Threat Detection. This service is a pivotal feature in the Security Command Center Premium tier. This advanced tool is designed to monitor and detect potential threats to your organization, acting as a vigilant security mechanism. Event Threat Detection operates by continuously scrutinizing log files across your entire organization or specific projects. When activated at the organization level, it immediately begins collecting and analyzing logs from projects as they are generated. By constantly monitoring these logs, it proactively searches for and identifies unusual or suspicious behavior patterns. Upon detecting a potential threat, Event Threat Detection generates an alert and creates a finding within the Security Command Center. Although Event Threat Detection is automatically enabled with the Premium tier, viewing and configuring requires appropriate permissions in Cloud Identity and Access Management, or Cloud IAM. Event Threat Detection is automatically activated with the Premium tier, but there may be occasions where you need to disable or enable this service for specific folders or projects. To do this, navigate to the Security Command Center. Click Settings. Locate the card for Event Threat Detection and click the Manage Settings button. In the Service Enablement section, you'll be presented with your organizational structure. Expand the tree to view all the folders and embedded projects. Select the object you wish to modify. We'll choose the App Development Project. In the Event Threat Detection column, you'll find a drop-down box where you can enable or disable the service for that specific project. We will select Enable. Now, Event Threat Detection is enabled for the App Development Project. Event Threat Detection operates through the use of rules. Rules define the type of threats that Event Threat Detection detects and the types of logs that must be enabled for detectors to work. Let's take a closer look at how these rules function. For instance, consider the scenario of detecting a brute force SSH attack. This kind of attack exploits weak or default passwords that are commonly used on servers. To identify such an attack using Event Threat Detection, it's essential to first enable the authentication log, commonly referred to as the auth log. Enabling this log allows the detection system to monitor and identify any successful brute force attempts on SSH hosts. Please consult the Google Cloud logging documentation for detailed instructions on how to enable various logging APIs. Remember, the effectiveness of the Event Threat Detection heavily relies on the appropriate configuration of these rules and logs. By ensuring that the correct logs are enabled and monitored, you significantly enhance the security mechanism's ability to detect and alert potential threats to your cloud environment. To gain a comprehensive understanding of the various rules available within Event Threat Detection, refer to the Security Command Center documentation. Event Threat Detection employs an array of built-in detectors, also called modules, to pinpoint various threats. Modifying these detectors can only be done at the organization level. To modify detectors, start by going to the Security Command Center, then clicking Settings. From the cards, select Event Threat Detection, then Manage Settings. The Service Enablement page displays. Click the Modules tab to view the list of detectors available. Each detector listed here offers the choice to enable or disable it. Next, we'll discuss how to create custom modules to tailor threat detection further. Now that we've reviewed built-in modules, it's time to look into creating a custom module, which will allow for even more targeted threat detection within the Security Command Center. To get started, click Create Module to open a wizard that facilitates the customization of modules for Event Threat Detection. The initial step involves selecting a module template. These templates are pre-existing detectors that you can tailor to your specific needs. For our demonstration, we'll use the Compute Engine Regions module. This module allows customization of specific regions for your threat detections. Click Select to proceed, and then give your module a name. We'll name ours Demo 1. Next, you have the option to specify the regions for scanning. You can either copy and paste a list of regions or use the drop-down list to select your preferred region. After making your selection, click Next to proceed to the Enter Finding Details section. On this page, you'll have an opportunity to define the severity of the findings, which ranges from critical to low. We'll set ours to medium for this example. It's also important to enter a detailed description of the module. A clear and concise description is vital for other administrators who may review this information and for clarity when findings are reported. However, for simplicity for this demo, we will just enter Demo. Additionally, you have the option to define steps for remediation. Providing step-by-step instructions for addressing potential threats detected by this module is crucial. This guidance is invaluable for administrators tasked with remediating any issues identified by the module. After entering the remediation steps, click the Create button to finalize your custom module. And that's it. You've now successfully created a custom module in the Event Threat Detection of the Security Command Center. This module will enhance your ability to detect specific threats tailored to your organization's unique requirements, improving your overall security posture. Now that we have reviewed the different detectors available with Event Threat Detection, let's intentionally trigger an Identity and Access Management or IAM anomalous grant detector and observe the generated findings. An anomalous grant finding is triggered when an IAM member is created outside of the organization's domain. Performing this step is essential for understanding how to monitor and manage potential security threats in your Google Cloud environment. Let's begin by setting the stage for our test. We'll initiate the process by using a test user with a Gmail account. Employing a Gmail account for this test should ideally trigger the anomalous grant we're aiming to detect. The first step involves navigating to the IAM and Admin section. From the Google Cloud's navigation pane, select IAM and Admin. This is where we'll introduce the test user into the scenario. In the list of principals, we locate the fictional user sccuser1223@gmail.com and click the pencil icon to edit. The next crucial step is to assign a role to this user. Click Add another role. In the drop-down list, choose Basic, then Owner. Assigning such a high-level role to a Gmail account is unusual and should set off our detector. Clicking Save will apply this change. Now, on to the next part, verifying the detection. Return to the Security Command Center by clicking on Security in the navigation menu. From here, click Findings. To pinpoint recent activity, the time range can be adjusted to filter the results to display recent triggers. For this demo, the trigger we're looking for, the Persistence IAM Anomalous Grant Finding, is right here. Once located, click on it to open the detail page. Here on the detail page, we're provided with an AI-generated summary which gives us a full breakdown of the activity, helping us to understand the exact nature of the threat and its potential impact. So there you have it, a first-hand look at the power and precision of event threat detection within the Google Cloud Security Command Center. This test not only shows the system's effectiveness in real time, but also gives us crucial insights into how to better protect our cloud environment against unconventional access patterns or security breaches. Finally, Security Command Center provides multiple ways to monitor and analyze threats detected by the Event Threat Detection system. One option is to simply navigate to the Security Command Center and select Threats from the left panel. This action opens the Threats dashboard, an intuitive interface designed for a detailed examination of potential and identified threats. Within the dashboard, users will find that threats are methodically categorized for ease of analysis. These categories range in severity levels, spanning from critical to low, enabling users to prioritize their response efforts based on the urgency of each threat. Additionally, threats are systematically organized by categories, offering a clear and concise overview of the nature and type of each detected threat. For instance, in our recent testing, one notable category highlighted was the Persistence IAM Anomalous Grant. This kind of categorization not only helps in quick identification of specific threats, but also aids in understanding their context and potential impact. Moreover, the Security Command Center allows for searching threats by project. This feature is particularly useful for organizations managing multiple projects, as it enables security administrators to isolate and focus on threats relevant to specific project environments. By selecting any of these categories or project-specific threats, users are directed to the Findings screen. Here they can delve deeper into each finding, accessing detailed information and insights. This level of detail is invaluable for thorough threat assessment and for formulating informed and effective security strategies. Overall, the Security Command Center's approach to threat management exemplifies a blend of comprehensive data organization and user-friendly navigation, ensuring that security teams are well-equipped to safeguard their digital assets effectively. This concludes our review of the Event Threat Detection for Security Command Center. Thank you, and see you in the next video.